Good day, viewers. In today's video, we are going to measure another type of roof. In the previous video, we measured monopitch roof. We use this drawing. So we measured a monopitch roof on this drawing. In today's video, we are going to make use of another drawing. A plan with gable roof. Let me add that drawing to the list of drawing we have here. I'll add this particular drawing to this video description so that you guys will have access to the drawing. I think the drawing is under Gable. Okay, I think it's on desktop. Gable Roof. Okay, that's the drawing. Yeah, now Gable Roof drawing. I think we have 4 numbers of drawing there. This is the first floor. And this is the roof plan. The section through the roof. And this is okay. This is the transverse section through this longitudinal section through the same roof. This is a gable roof. A gable roof is a type of roof that slopes in 2 directions. When you have your roof sloping in 2 directions this way, it's a gable roof. That type of roof is called gable roof. Okay, so we are going to measure this the way we did in the previous video. Okay, we have the roof members listed here already. The aluminum ridge cap, long span aluminum roofing sheets, 50 by 75 mm hardwood purlin, spaced at 900 mm center to center, 50 by 150 mm hardwood rafters at 120 center to center. I know I told you guys the other time. They didn't state the spacing, but I told you guys that it's usually 120 center to center. The rafter, the struts, and bracing, even the tie beam too. The whole thing is spaced at, that's the conventional spacing, 120 center to center. 1.2 center to center. And the noggin, I know I told you guys too that the noggin, we assume 600 by 600. As you can see, this particular noggin is 600 by 600. Okay, so let's start with the first item. In the previous video, the first item we measured was wall plates. Yes. So in this video too, we're going to measure wall plates. The first item here will be wall plates. From this roof section, what we have here is slope in 2 directions. This direction, and the other direction. This direction and the other direction. So we have our setup of rafter, tie beam, and king post and struts arranged in this way, this direction. Our strut, rafter, tie beam, the whole setup will be arranged in this direction. Like we have them in this direction at 1, 2 center to center in this direction. While our purlin will span across the length of the building. Okay, so let's go back to our roof section. We're going to measure our wall plate on this particular drawing. Yeah, I'm going to measure our wall plate on this particular drawing. Now I told you guys that the first item to be measured, or that particular roof member that actually have like direct contact with the wall, like the building wall, it's the wall plate. So that's what we're going to measure. And that's measured in linear meter. We're going to make use of our linear tool. But before then, we have to scale this drawing. So let me quickly scale this drawing. I'm going to make use of this scale, 18.975. 18.975. 18.975. So that will be from this. Okay. Then let me scale the breadth of the building. That's 14.0. 14.0. Then the last step is to cross-check your scale. So let's cross-check. Cross-check what you've scaled. If your scaling is right or wrong. Okay, I think our scaling here is right. Let me check another dimension. Let me check this. It's very important to scale and cross-check your scale, because your measurement depends on your scale. If your scale is wrong, then whatever you measure using that scale will be wrong. So I think our scale is correct. I'm going to click on this to put off those dimensions. Okay, so they won't disturb us during the process of measurement. So let's quickly measure our wall plate. I think I'll have 4 wall plates here. I'll have 4 wall plates, but maybe this be able to run through. Okay, no problem. My wall plate will run through. I'll have 4 wall plates. I will have 4 wall plates. I'll have wall plates along this part of the building. I have another one here, another one here, and another one here. I think that should do. I'm going to make it our linear tool, and this will be our wall plates. Let me okay. Wall plate 2. We measured the wall plate in our previous video. Under monopitch roof, we measured the wall plate. So since I'm measuring another wall plate here, I'm going to I'm going to add to the description of whatever roof member we're going to measure in this video. So I'll be able to differentiate whatever we've measured now from what we measured in the previous video. Although at the end of the day, we don't need those drawings because that's not what we'll be working with. So I want to measure the actual plan we'll be working with at the end of the day. But I just want you guys to have in-depth understanding of how to measure roof members. Let's proceed. This will be under roof. Our plate from this point. Okay. Next, and we have another running from this point. Oh, so I'm taking from the external parts of that wall. It will run through this way this time around. The third one. And the last one. Last wall plates. Okay, so I'm going to click on my escape button to deactivate this. Okay, we have our wall plate measured already. Then let's measure other member. We're going to measure other member on the other drawing, not this drawing. But we need to calculate the numbers of setup. We have, since our spacing is 1, 2, and the arrangements will go this way. Let me use my segment 2. So we have our setup arranged this way. So this is our setup, we arranged this way. But I want to pick this particular dimension and we divide this dimension by the spacing to get the numbers of setup. The length here is 18975. Let me make it on my calculator. 18975. 18975 divided by 1200 plus 1. Should we add 1 to it? No. So we have approximately 16 setups. 16. So let's work with our 16. Okay. So whatever we measure here, we multiply that by 16. You can measure this using our linear tool. Oh, we've not scaled this drawing. So let's quickly scale the drawing. The distance from this point, like from this point to the top of the roof, like from the from the floor level to the top of the roof is 7.9 meters. 7.9 meters. Scaled. Okay, let's cross check. What did you scale? Or should we just scale something else? Should we scale? Let's pick this. Let's scale this too. Sorry. Fine, yeah. Okay, let's cross check what we just scaled. Let me check something else. Let me check another dimension. Something is wrong. No. Let me delete this and rescale. Let me move cross check with this scale alone. Wow. Body is right. So assume the scale that was used for the internal dimension is different from the scale that was used for the external dimensions. Yes, it does. So what should we do? Let's work with the external. Let's work with this. Or let's delete this and rescale this. I don't know what to do. Okay, let's work with this. Okay, so let's measure our tie beam. Our tie beam is the bottom member here. It spans from this point to this point, and from the division we did the other time, we have 16 setup. We want to measure that with the aid of our linear tool. So I will name that tie beam. Okay, tie beam 2. From this point, this is not the external part of the building. Escape. This is times 16. If to multiply this by 16, you double click on this and you click on advance. Then you input 16 here times 16. Okay, measured. The next member here is our rafter, and that will be times 16 too. So let's measure our rafter. Rafter 2. The member from times 16 times 16. The next member I want to measure here is the strut. For gable roof, the middle strut here, this particular strut here, is called the king post. The king post, the longest strut, is called the king post. King post 2. That will be from this place. Come to this place. Escape. These are our polling. 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 Okay. Our king post is times 16 too. Times 16. Then the next member here is the strut. These other members. These smaller ones, the vertical ones, they are called queen posts. But I want to call the whole thing strut. They are called queen posts. And I think these they are called bracing. As the case may be, but the whole thing here is strut. Strut 2. And that'll be from this place. Yeah. I think that's all. That's all. What do we have left? Yeah, our Pauline. The next member here is our Pauline. And I'm going to measure that on this plan. I'm going to measure our Pauline on this plan with the aid of our joist tool. So let's measure our Pauline. Our dimension is earlier. Joist 2, pitch, let's leave it at 0. Oh, sorry, the roof pitch here is not stated. Let's use 15. It's not stated. Like I said the other time, you can calculate your pitch using. Let's calculate it. Let me close this. Okay, so we can actually calculate using. We can calculate our pitch. The pitch here is like the slope, the angle here. So we can. I told you guys in the previous video, I can calculate our pitch using our SOCAT tool. What I'm going to make use of here is tan. Tan is opposite over adjacent. So let me check the dimension of what we have here as arcing post. Arcing post is 1.59, 1.59, and distance from this place to this place is 6.9, 1.59, 6.9. Let me close the scientific calculator on my phone. We're going to do shifts. What is it? Shifts tan opposite 1.59 over adjacent 6.9. I think something is wrong with this calculation. .59. Let's proceed with our measurement. Normally, this thing should be stated. The slope should be stated, but since it's not stated, let's make it our joist tool, and we'll just use. Let's use 15 or 20, but it should be stated. So you can if it's a real life project, you can contact the architect. Spacing here is 900 center to center, 0.9, and uncheck this too, but don't uncheck this. So at the end of the day, the software will automatically sum up the whole poly together, group section. This is the first part of the roof. And this is the other part. Skip. Okay, now let's draw. Click on this, then click on draw joist. Yes, and we draw. Okay, do the same here too. We have our column measured already. Let's check the value. The value here is 297.0, 297.0 measured. I think those are the um, basic roof members. In the previous video, I showed you guys how to measure noggin. So the measurement of noggin here too is the same. So I'm not going to repeat that. I'm going to make another video where I will use my roof plugin instead of using the basic tool on PLANSWIFT. So we'll cross-check the results. See you in the next video.